students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as rotational. Now, let's find out angular momentum. What do we understand by angular momentum? Let's consider a rigid body. Let's consider O is the point where the axis of rotation passes through. Consider that the rigid body is made up of many points of mass m1, m2, m3, m4 and so on situated at a distance of r1, r2, r3 and r4. Right? So I can say consider a rigid body. Consider a rigid body rotating with uniform angular velocity omega. So omega is the velocity with which the body is rotating, right, about an axis of rotation. About an axis passing through point O. Passing through point O. Now, a section of the body, let's consider a section of the body. Now, let us suppose that the body is made up of n particles. Let us suppose the body is made up of n particles of masses m1, m2 up till mn situated at a distance of r1, r2 up till rn from the axis of rotation. Right? Now, we will just take one point mass. So let us consider a particle of mass m1. Consider a particle of mass m1. Now, as the body is rotating, that particular particle will be moving in circle, right? Revolving in a circle of radius. Revolving in a circle of radius. Revolving in a circle of radius r1. Now let's assume that the linear velocity of the body or the linear velocity of the particle is v1. Let linear velocity be equal to say v1. Now in that case I can therefore say that v1 is equal to r1 omega. That's my relationship between linear velocity and angular velocity. Now linear momentum P1, momentum is nothing but the product of mass and velocity, so that is going to be m1 v1. So m1 v1 r1 omega. Fine, do we get this thing clear? Now, the linear momentum about the axis of rotation is equal to linear momentum into the moment arm. I can say that the moment of linear momentum is given by the formula linear momentum into the moment arm linear momentum into the momentum. Now, in that case, I can say that, let's assume that the moment of linear momentum L1 is nothing but P1 into R1. So P1 we had found out is M1 R1 omega into R1. So that will be nothing but M1 R1 square into omega. Right? Now similarly, I could find out the linear momentum for all the other bodies, and correspondingly I could find out the moment of linear momentum for all the other points. Similarly, the moment of linear momentum for other points can be found. Therefore, I can say that if I add all this moment of linear momentum, what I get is called as angular momentum, right? So I can say that the sum of the linear momentums of all the particles, the sum of the moments of linear momentum of all particles is called as angular momentum. So angular momentum L can be written as L1 plus L2 plus Ln. So angular momentum is nothing but it is the sum of the moment of linear momentum of all the particles. Therefore, I can say L is m1 r1 square omega plus m2 r2 square omega mn rn square omega. Here I could take omega common, so this will be nothing but m1 r1 square plus m2 r2 square plus mn rn square omega, but this can be written as sum of I is equal to 1 to n mi ri square into omega, but mi ri square is nothing but moment of inertia, so I can say L is equal to I omega. So angular momentum is defined as a product of moment of inertia and angular velocity, right? So I can say therefore angular momentum is equal to of a body is equal to the product of its moment of inertia is equal to the product of its moment of inertia and angular velocity. Fine. Now in that case, what will be the units? SI units. It is nothing but moment of inertia into angular velocity. Moment of inertia kg, angular velocity kg meter square per second, and the CGS units will be grams centimeter square per second, right? Dimensions. Dimensions are going to be nothing but m1 l2 t minus 1. That will be your dimensions of angular momentum, right? Next, let's try to find out the relationship between linear momentum and angular momentum. Linear momentum and angular momentum. Now we know that linear momentum is defined as the product of mass and velocity. Linear momentum is the property that is possessed by a body in translation motion. I can say that linear momentum is a property possessed by a body in translational motion. Right? It is defined as product of mass and velocity. Thus I can say that linear momentum P is mv. Right? I can say that it as a vector form it is nothing but P vector is equal to m into v vector. This is in vector form. Now I can say that the similar quantity, what is angular momentum? It is equivalent, it is analogous to what you have linear momentum. It's analogous in rotation motion is angular momentum, right? So I can say that the similar quantity in rotational motion, the similar quantity in rotational motion is angular momentum, right? And it is defined as, so it will have same definition. It is defined as the product of moment of inertia and angular velocity. So what linear momentum is for translation motion, angular momentum is for rotational motion, right? Now, therefore I can say L is I omega, right? Now, let's see law of conservation of angular momentum. Conservation of angular momentum. Let's try to understand law of conservation of angular momentum. If angular momentum is synonymous to angular momentum is the same for rotational motion as linear momentum for translation motion, then it should follow all the principles of linear momentum. Since linear momentum is conserved, let us see if angular momentum is also conserved. So what we will say is, consider a body in translation motion always obeys conservation of linear momentum. Similarly, a body in rotation motion should also obey conservation of angular momentum. Now, in that case, the law states, if no external torque acts on a rotating body, if no external torque acts on a rotating body, if no external torque acts on a rotating body, the angular momentum of the body remains constant. The angular momentum of the body remains constant. Let's prove this. Let's see the proof for this. Now, let's assume that the torque acting on, let's assume that T is the torque acting on the body. Let's assume that T is the torque acting on the body and I is the moment of inertia. I is moment of inertia of the body. Let's assume that alpha is the angular acceleration. Right? In that case, I can say that angular acceleration produced by the body, then I can say that T is nothing but I alpha, right? But omega is nothing, but alpha acceleration is rate of change of velocity, right? Therefore, I can say alpha is nothing but d by dt of omega, right? So I can therefore say that torque is equal to I can substitute the value of alpha as d by dt of omega. Instead of alpha, I can write d by dt of omega. So I can say torque is d by dt of I omega, right? But we know that I omega is equal to L, right? Therefore, I can say that torque is d by dt of L, right? Now, if the torque acting on the body becomes is equal to the time rate of change of angular momentum, that means in that case there will be no external torque acting on the body, and if external torque acting on the body becomes zero, then the angular momentum will become constant, because d by dx of constant is zero. And if angular momentum becomes constant, that means momentum is conserved. So I can say that if torque acting on the body, if torque acting on the body is equal to the time rate of change, equal to the time rate of change of angular momentum, what is this? This is what I've just written. T is equal to d by dt of L. In words it is written this way, right? Thus torque acting on a body is equal to time rate of change of angular momentum. So if no external torque acts on the body, no external torque acts on the body, then T will be equal to 0. Therefore, but T is equal to d by dt of L. So 0 is d by dt of L. Therefore, L is constant. But what is L? L is nothing but your angular momentum, and thus angular momentum is constant, right? So thus, if no external torque is acting on the body, the angular momentum of the body remains constant, and this is my law of conservation of angular momentum. Thus, if no external torque acts on the body, the angular momentum of the body remains constant. The body remains constant. Fine, do we get this in here? Now, once I know that the angular momentum is constant, that's my law of conservation of angular momentum, which is law of conservation angular momentum. Fine, do we get this in here? Let's start with the numericals. This finishes the theory. Let's start with the numericals. Take down please. A disk of mass 600 grams, a disk of mass 600 grams is rolling on a horizontal surface, with uniform velocity of 4 meters per second. Calculate its total kinetic energy. Now, kinetic energy is nothing but, for a rolling body, is nothing but translational energy plus rotational kinetic energy. That's the total energy possessed by a rolling body. Now, translational energy is nothing but half mv square plus rotational energy is nothing but half, for a disk, I omega square. Right? Now, I can say that but for a disk, I can say moment of inertia is nothing but mr square by 2, and we also know that V is equal to r omega. Therefore, I can say that omega is V upon r. And if I substitute this, I will get total kinetic energy is going to be half mv square plus half I can be written as mr square by 2 into omega v square by r square, because that's omega square. So r square and r square gets cancelled. So this is nothing but 1 upon 2 mv square plus 1 upon 4 mv square. I could take mv square common. So this is going to be 2 plus 1, 3 upon 4 mv square. I know m, I know v, I should be able to get the answer. The answer for this sum should be 7.2 joules. Next, take on next one please. A torque of magnitude 800 Newton meter acts on a body of mass 50 kgs and produces an angular acceleration of 20 radians per second square. Calculate the moment of inertia of the body. And the radius of gyration. Torque, I know, is nothing but I alpha. So in which case alpha I have, torque I have. So I'll come to know the moment of inertia. Straightforward, just divide. You should get this answer. Now, I can say that second thing they've asked you to find out is radius of gyration. Radius of gyration is nothing but I upon m. I already know m is given to me. I should get the answer for this also. Answer for this sum should be I should be equal to 40 kgs meter square and half k radius of gyration should be equal to 0.8994 meters. Next, take down next one please. When an angular momentum of a body changes from 10 radians per second to 20 radians per second. When the angular velocity of a body changes from 10 radians per second to 20 radians per second, its angular momentum changes by 60 kg meter square per second. Find the change in kinetic energy. Find the change in kinetic energy. Now guys, angular momentum L can be written as I omega 1. Similarly, L2 can be written as I omega 2. Therefore, L2 minus L1 will be nothing but I omega 2 minus I omega 1. L2 minus L1 we know is 60. I common. Omega 2 minus omega 1. So I get 60 is equal to I omega 2. 20 minus 10. So I get I is equal to 6 kg meter square. I got the moment of inertia, but they haven't asked me moment of inertia. They've asked me to calculate the change in kinetic energy. Now kinetic energy possessed by the first body, half I omega square. Similarly, kinetic energy possessed by the second body is half I omega 2 square. Therefore, change in kinetic energy E2 minus E1 is half I common omega 2 square minus omega 1 square. I you have already found out, you know omega 2 and omega 1. You should be able to get the answer. The answer for this sum should be 900 joules. Next, take down next one please. A thin uniform rod has a length of 20 centimeters and a mass of 300 grams Find the moment of inertia and the radius of gyration. Find the moment of inertia and the radius of gyration about an axis passing through its midpoint, and perpendicular to its length. I is equal to ml square by 12 for a rod. I is equal to ml square by 12. I know ml, I know 12, and k is root of I by m. I would have found out. M is given to me. I should be able to get the answer for this. The answer for this should be I is 10 raised to minus 3 kgs meter square, and k is 5.77 into 10 raised to minus 2 meters. Next, take down next one please. A flywheel in the form of a disc. A flywheel in the form of a disc is initially at rest. It attains a speed of 420 rpm. It attains a speed of 420 rpm when a constant torque acts on it. For 1.5 minutes. When a constant torque acts on it for 1.5 minutes. If the radius and the mass of the disk is 0.6 meters and 15 kgs, find the torque. Now, I can say for a disk, moment of inertia is nothing but mr square by 2, but they've asked me to find out torque. T is nothing but I alpha. Alpha is nothing but omega 2 minus omega 1 upon t. Angular acceleration is change in angular velocity upon time. So I omega 2 minus omega 1 upon t. Omega is nothing but 2 pi n. So I can say that I is not I 2 pi n2 minus 2 pi n1 upon t. So torque is equal to 2 pi I n2 minus n1 upon t. Now I can be written as mr square by 2. So torque will be equal to 2 pi mr square by 2 n2 minus n1 upon t. 2 and 2 gets cancelled. So this is nothing but pi mr square n2 minus n1 upon t. That will be the torque, right? You should get this answer as 1.32 Newton meter. Next, take down next one please. A flywheel is rotating on a shaft. At 600 rpm. A second identical wheel initially at rest is suddenly coupled on the same shaft. Find the angular speed, find the angular speed of the resultant combination, find the angular speed of the resultant combination Now, I can say that for the two wheels, the initial momentum, let's call this as L1. Initial momentum is going to be nothing but the sum of the momentum of the system. There are two wheels here, so that will be I1 omega 1 plus I2 omega 2, right? So this is going to be I1, we said is I. They've said that both the wheels are identical. Therefore, the moment of inertia of the two wheels will be same. Omega 1, 2 pi n1 plus I, 2 pi n2. So in that case, you will get 2 pi I n1 plus n2. That will be the initial momentum of the system. Now let us assume that omega 3 is the final angular velocity after the wheels are coupled. Let omega 3 be the final angular velocity after the wheels are coupled, right? So in that case, if omega 3 is the final angular velocity, in that case n3 will be my final RPM, will be the RPM or RPS to be precise of the resultant combination. So in which case I can therefore say that L2 is going to be nothing but final momentum of the system is going to be both the wheels have been coupled together. So that will be nothing but I1 omega 3 plus I2 omega 3. Since both the wheels have been coupled together, they will have the same angular velocity. Both of them are going to be moving with the same speed. So in that case, I could therefore say, now I1 is equal to I2. So therefore, I can say that L2 will be I 2 pi n3 plus I 2 pi n3. So this is going to be 2I into 2 pi n3. So this is 4I pi n3. 4 pi I n3. Now, by law of conservation of angular momentum, I can say that L1 should be equal to L2. By law of conservation of angular momentum, L1 should be equal to L2. That means 2 pi I n1 plus n2 should be equal to 4 pi I n3. Pi and pi gone, I and I gone, 2 ones are, 2 twos are. So I'll get n1 plus n2 should be equal to twice n3. Therefore, n3 will be equal to n1 plus n2 upon 2. You have the value of n1, you have the value of n2, you should substitute and get the answer. You will get your answer. The answer should be 300 RPS. Next, take on next one, please. A uniform solid sphere. A uniform solid sphere has a radius. A uniform solid sphere has a radius of 0.2 meters, has a radius of 0.2 meters and a density of 24 into 10 raised to 3 kgs per meter cube, and density of 24 into 10 raised to 3 kgs per meter cube. Find the moment of inertia about first part of the question, its diameter. First part of the question, its diameter. Second part of the question, tangent to its surface. Tangent to its surface. Now, first of all, I can say let's find out the mass of the sphere. Mass of the sphere will be volume into density. Volume is 4 by 3 pi r cube into density is rho. So I'll come to know the mass of the sphere. Once I know the mass of the sphere, then I can find out the moment of inertia about diameter. Moment of inertia about diameter is nothing but 2 upon 5 mr square, right? That will be the moment of inertia about the diameter. Then similarly I can also find out moment of inertia about tangent. Moment of inertia about tangent is given by the formula 7 upon 5 mr square. You should be able to get this answer. Next, read on next one please. The speed of rotation of a body, increases, from 120 rpm, to 180 rpm in 2 minutes. If the moment of inertia of the body is 700 kg meter square, find the torque acting on the body. Now, torque, guys, we know is nothing but I alpha. This is nothing but I. Alpha can be written as omega 2 minus omega 1 upon T. Omega can be written as 2 pi n. So I 2 pi n2 minus 2 pi n1 upon T. Here I could take 2 pi common. So this is n2 minus n1 upon T. I know I, n1, n2 and T. I should be able to get the answer for this. Answer for this sum should be 36.66 Newton meter. Right, take the next one please. A ballet dancer spins about a vertical axis. At 180 rpm. With her arms stretched. With the arms folded. the moment of inertia decreases by 40%. The moment of inertia decreases by 40%. Calculate the new rate of revolution. Calculate the new rate of revolution. Calculate the new rate of revolution. Right? Now, let's see this. I can say that I2, the final moment of inertia, will be I1 minus 40% of I1. So I2 will be 60% of I1. Fine. Now, I can straight away apply law of conservation of angular momentum. I can say by law of conservation of angular momentum, if I apply law of conservation of angular momentum, then I can say that I1 omega 1 square should be equal to I2 omega 2 square. I1 omega 1 square should be equal to I2 omega 2 square. Sorry, I1 omega 1 should be equal to I2 omega 2. Right? Now, I have all the values. I can say that I1 omega 1 can be written as 2 pi n1. I2 can be written as 60 upon 100 into I1. Omega 2 can be written as 2 pi n2. So 2 pi gets cancelled. I1 gets cancelled. That leaves you with n1. N1 is 60% of n2. Right? You should be able to get the answer for this. Right? Your answer should be you should get is 300 rpm. Next, take on next one, please. Assuming that the earth is a sphere, calculate the moment of inertia. Calculate the moment of inertia about its own axis. Calculate the moment of inertia about its own axis if the angular velocity of the earth is 7.3 into 10 raised to minus 5 radians per second. Calculate the kinetic energy of rotation. Calculate the kinetic energy of rotation if the radius of earth is 6.4 into 10 raised to 6 meters and mass of earth is 6 into 10 raised to 24 kgs. Mass of the earth is 6 into 10 raised to 24 kgs. Now, first let's find out the moment of inertia of the earth. Since the earth is a sphere, I can say that moment of inertia of the earth will be nothing but 2 upon 5 mr square. Right, for a sphere, moment of inertia is nothing but 2 upon 5 mr square. Once I know the moment of inertia of the earth, the next thing they have asked me to find out is kinetic energy. Kinetic energy is half I omega square. Right? So in that case, I can say that the answer for this some straightforward multiplication you have. The answer is 9.813. That's your moment of inertia is 9.831 into 10 raised to 37 kg meter square, and kinetic energy is 2.619 into 10 raised to 29 joules. Right? Next, take on next one, please. The radius of gyration of a body, about an axis, at a distance of 5 centimeters, from its center of mass, is 13 centimeters. Find the radius of gyration. About a parallel axis. Passing through its center of mass. Find the radius of gyration about a parallel axis passing through its center of mass. Right? Let's assume this axis to be, say, IC and this axis to be IO. So you'll say let KC and KO be the radius of gyration. Let KC and KO be the radius of gyration about of the center of mass and the axis at a distance of 5 centimeters. Right? Now, I can straight away apply theorem of parallel axis. I can say by theorem of parallel axis, right? By theorem of parallel axis, I can say that IO is equal to IC plus MR square. Right? Now, IO is going to be nothing but M into KO square. IC is M into KC square plus M into R square. M is common, therefore I can say that KO square is equal to KC square plus R square. Right? Do we get this in here? Since everything is in centimeter, I shouldn't have a problem. I should straight away get the answer for this as 12 centimeters. Next, take on next one, please. A disc is freely rotating. About a vertical axis. Passing through its center at a rate of 200 rpm. A blob of wax of mass 40 grams. Falls on the disc falls on the disc at a distance of 5 centimeters from the axis. At a distance of 5 centimeters from the axis. If the moment of inertia of the disc about given axis is 4 into 10 raised to minus 4 kg meter square, find the new frequency of rotation. Now guys, can you see the figure please? I know the moment of inertia about the axis, right, passing through the center. I want to find out the moment of inertia about the axis passing through the blob. Now the axis passing through the center and the axis passing through the blob of wax are going to be parallel to each other. So straight away I can apply theorem of parallel axis. First of all, I'll say let I2 be the moment of inertia of the disc after the blob falls on it. The blob falls on it. So in that case, by theorem of parallel axis, if I apply theorem of parallel axis, I can say I2 is nothing but I1 plus mr square. M I know, R I know, I1 is given to me. So I'll come to know I2. Now, before the blob fell on the flywheel and after it falls, the angular momentum should remain the same. So then I can say by law of conservation of angular momentum, I1 omega 1 should be equal to I2 omega 2 I1 into 2 pi n1 should be equal to I2 into 2 pi n2. 2 pi gets cancelled, so I1 n1 should be equal to I2 n2. Right? Now substitute the values and you should get your answer. Answer for this should be n2 should be 160 rpm. Right? Next, take on next one please. A circular disc of mass 20 kgs and radius 0.3 meters is rotating about an axis passing through its center, and perpendicular to its plane using a torque of 25 Newton meter. Yeah. A circular disc of mass 20 kgs and radius 0.3 meters is rotating about an axis passing through its center and perpendicular to its plane by applying a torque of 25 Newton meter. Calculate the angular velocity. of the disk at the end of 5 seconds. Calculate the angular velocity of the disk at the end of 5 seconds. Now, I can say that for a disk, moment of inertia is nothing but mr square by 2. I can also say that torque is nothing but I alpha. I can substitute torque is mr square by 2 into alpha. Alpha can be written as, they've asked me to find out alpha. I can say alpha can be written as omega 2 minus omega 1 upon t. Do we know omega 1 or omega 2? They are saying that a circular disk is set into rotation. I can say since the disk is set into rotation, therefore omega 1 should be 0 radians per second. So I know omega 1, so I should be, the only unknown is mr, I know, t I know, small t I know, omega 2 is the only unknown. You should be able to get the answer for this. Answer, omega 2 should be 138.9 radians per second. Next, take down next one please. The radius of gyration of a disk, about an axis, passing through its center and perpendicular to its plane is 5 centimeters. Determine the radius of gyration of the disk. About its diameter. They have given me the moment of inertia about the center. They are asking me the moment of inertia about the diameter. Now I can say that for a disk, moment of inertia guys, for a disk I can say moment of inertia about an axis perpendicular to the plane, is IC, which is nothing but mr square by 2. For a disk, moment of inertia about an axis through its diameter ID is nothing but mr square by 4. Now they have given you that the radius of mr square by 4, right? Now they give me that the rate from these two equations. When I compare these two equations, what we see, guys, when I compare these two equations, what we see is that IC is mr square by 2 and ID is mr square by 4. That means I can say therefore ID is half IC. Moment of inertia of the disc about the diameter is half the moment of inertia about the center. Now moment of inertia is mk square, so mkd square is half mkc square. M and M gets cancelled, so kd square is kc square by 2. Kc, I presume they've given you. Moment of inertia about the center is given to you 5 centimeters, right? Where they've given you that Kc is 5 centimeters, which is nothing but 5 into 10 raised to minus 2 meters. So you should be able to get the value of Kd. The answer for this should be 3.54 centimeters, right? Okay, we'll stop this here for the day. Thank you very much.